For Unit 4, Objective 4, we're not just simplifying rational expressions anymore by adding, subtracting, multiplying, or dividing them. We're actually now solving rational expressions. And you know the difference because you see the equal sign. Anytime there's an equal sign, it's not an expression, it's an equation, and it's time to solve. So, the three examples I've got for you, first of all, will help you through problems 1 through 8 on worksheet 4. Example number 1 is pretty much as simple as it can possibly get. You've got one fraction being set equal to another fraction. So all we have to do is cross multiply and create our equation and then solve. But first of all, let's go back to objective 1 where we talked about excluded values. Remember, the denominator can never equal 0. So let's look at our two denominators. We got to figure out what are the values of x that we have to avoid. So the first one over here on the left is pretty easy. I just have to say x minus 5 cannot equal 0. So therefore, x cannot equal 5. There's my first restricted value of x. And then the other one, that might take a little bit more work, but it's the same idea. 2x plus 14 cannot equal 0. So just start solving. Subtract 14 from each side. 2x cannot equal negative 14, which means x cannot equal negative 7. Now, those two values are playing an important role in the rest of the problem, because when I do solve the problem and I come up with one solution for x in this case, we need to make sure that that x is neither 5 or negative 7. If it's either one of those two numbers, we have to throw it out as being an excluded value. It can't be either one of these numbers. So, let's just start working this thing out. It's just a matter of cross-multiplying. When there's a fraction on one side and a fraction on the other side and an equal sign between them, we just cross-multiply. So 8 times 8x minus 5. Remember that 8 needs to get distributed as if the x minus 5 had parentheses around it, and you would get 8x minus 40. Now, when you go the other way, 2 times 2x plus 14 is 4x plus 28. So there's my equation, and now it's just time to solve. I'm going to bring the 4x's this way, subtract 4x, subtract 4x. And since I brought the x's that way, that means I need to take the number, the constant, the other way. So now I'm going to add 40, and my new equation is 8x minus 4x, which is 4x equals 28 plus 40, which is 68. Now divide both sides by 4, and you're going to get x equals 17. Now, since 17 is neither 5 or negative 7, we know it's okay. Example number 2 is the same concept as example number 1. I've got a fraction on the left, I've got a fraction on the right, and I've got an equal sign in the middle, which again means I'm going to be cross-multiplying to create my equation. But before we do that, let's worry about the restricted value or values again. This time I look at my denominators, and one denominator simply has a 7 in it. The other one has x plus 3. So we only need to worry about the possibility that the left fraction denominator could equal 0. So let's just set up the equation that x plus 3 cannot equal 0. So subtract 3 from both sides. X cannot equal negative 3. So there's my restriction. Now let's get on with solving the problem. If I multiply x squared minus 5 times 7, so when I do this cross multiplication, don't forget I need to distribute the 7, so it would be 7x squared minus 35 equals, now a little binomial multiplication, x plus 7 multiplied by x plus 3 is x squared plus 10x plus 21. Now this is a quadratic. I want to set my quadratics equal to 0. So everything over here on the left, x squared plus 10x plus 21, needs to go over here on the right. So one by one, I'm going to subtract the x squared. I'm also going to subtract the 10x, but it really doesn't have any place to go because there aren't any other terms with just x. And I'm also going to subtract the 21. I'm going to put that right under the minus 35. And now I have an equation that says 7x squared minus the x squared that I brought over is 6x squared. Here's my minus 10x that I'm going to put right here. And then minus 56 equals 0. Now it's time to factor this. I see a greatest common factor. All three of those terms are divisible by 2, so I'm going to factor out the 2. And that's going to leave me with 3x squared minus 5x minus 28 equals 0. It's still a guess and check factor. So I'm going to put that 2 right out there. Don't forget the 2 that you factored out. Now the way to factor 3x squared minus 5x minus 28 is I'm going to put a 3x right there. I'm going to put an x right there. I'm going to use the combination of 7 and 4. And if I put the minus 7, no, I'm going to use a plus 7. I'm going to put a plus 7 right there. And I'm going to put a minus 4 right there. Now, if you FOIL this out, 3x times x is 3x squared. Your outside terms are negative 12x, and your inside term is positive 7x. So a negative 12x and a positive 7x make your negative 5x, and then 7 times negative 4 is negative 28. So here we have the problem fully factored. Now it's time to get solutions. The 2 isn't going to give us an answer, but the 3x plus 7 is going to give us an answer. So 3x equals negative 7, x equals negative 7/3, and then the x minus 4 is also going to give us an answer by setting it equal to 0, so x equals positive 4. So there are my 2 answers, neither of which is negative 3, because negative 3 is the restricted value for this problem. So we're good. Example number 3 is a little bit more complicated in the fact that it's not a problem that you simply cross multiply. Notice on the left-hand side of the equation, I have 2 fractions, and on the right-hand side, I only have 1. So I cannot just cross multiply in this problem. what I want to do is clear the fractions. That's going to be the key to the problem, clearing the fractions. Now, I'm looking at this denominator right here, and I see that it's factorable. So I'm going to factor this problem. I'm going to cross out the x squared minus 5x, and I'm going to rewrite it in its factored form. I'm going to factor out an x as the greatest common factor, and I'm going to be left with x minus 5. Now, that tells me a lot, because this fraction has a denominator of x, this one has a denominator of x minus 5, and this one has a denominator of x times x minus 5. So, the key to this problem, in order to clear the denominator, I'm going to multiply all the terms in this problem by the least common multiple of x times x minus 5. So I set the next step up to where I'm going to do exactly that. Every part of this fraction is going to get multiplied by x times x minus 5. X times x minus 5. X times x minus 5. Now, watch all the reducing that happens, because at the next step, I am going to have an equation that has no fractions in it anymore. That's the whole idea of multiplying all the terms by the least common multiple. It's going to get rid of the fractions. On the first one, the x's are going to reduce each other. On the second one, it's going to be the x minus 5s. And on the third one, it's going to be both things, because remember, x squared minus 5x was actually x times x minus 5. So the x's are going to reduce each other. The x minus 5s are going to reduce each other. So that means all three denominators have now gone away, and I don't have any more fractions. Now we just take each term one by one. 5 times x minus 5 minus 7 times x equals 21. So 5x minus 25 minus 7x equals 21. Now on the left-hand side, I've got some simplifying to do. Combine like terms. 5x minus 7x is negative 2x minus 25 equals 21. Add 25. Negative 2x equals 46. Divide both sides by negative 2. X equals negative 23. Now, something we forgot, or something I forgot, is the restricted values. If I look at my denominators, go back to the original problem. On the first fraction, we learned x cannot equal 0. On the second fraction, we learn x cannot equal positive 5. And since the third fraction is made up of the other two, we're done. So here are my restricted values. X cannot equal 0. and x cannot equal positive 5, and that's okay, because the answers we really got, or the answer we really got for the problem was x equals negative 23. Example 4 is similar to example 3, and there are quite a few problems on worksheet 4 that go like this. This is one of those problems I can't get away with simply cross-multiplying, because here's the equal sign, and there are two fractions on the left, and there's only one on the right. So, I need to look at that denominator for a second. I see that it is not factored, so I'm going to factor it. What are the factors of negative 10 that add up to positive 3? It happens to be x plus 5 and x minus 2. And you'll notice that that happens to be the product of the other two denominators. So let's worry about our excluded values first. Everything's factored, so I know x cannot be negative 5 or positive 2. Either one of those values of x, we're going to have to throw out if that's one of our answers. Now, the next thing, let's multiply the equation by the product of the two denominators, because the least common multiple is x plus 5 times x minus 2. So that's going to be the key to the rest of this problem. Down here, I rewrote the problem again. I'm going to do what I did up here. I'm going to cross out the denominator in its unfactored form, and I'm going to write it in its factored form. That'll make it a little bit easier to see why multiplying the entire equation by x plus 5 times x minus 2 is going to very conveniently clear all the fractions. Now, I'm not going to do it as slowly as I did on example number 3. We just need to know that this goes here, and it goes here, and it goes here. Now, we need to figure out when x plus 5, x minus 2 gets distributed to this first fraction. What is it that will cancel? It'll be the x plus 5, leaving just the x minus 2. Now, moving on to the second term. It's minus 3, and on the second term, it's going to be the x minus 2's that cancel. And I'm going to be left with an x plus 5. Now, after the equal sign comes the third term in the problem, which is 14 over x plus 5, x minus 2. Well, when 14 gets multiplied by x plus 5, x minus 2, but it's over x plus 5, x minus 2, those are both going to cancel, and all you're left with is the 14. So now it's just a matter of cleaning up the problem and seeing what we end up with. We've got x squared minus 2x after we distribute the x. Now, minus 3x minus 15 equals 14. So, clean up the left-hand side. Negative 2x and negative 3x combined like terms makes x squared minus 5x minus 15 equals 14. Now, since it's a quadratic again, I'm going to make it equal 0 by subtracting 14. And that leaves me with x squared minus 5x minus 29 equals 0. Now this is not factorable. There are no factors of negative 29. Negative 29 is a prime number, so there are no factors of 29 that give me a sum of negative 5. So I'm going to use the quadratic formula to solve this answer. Just as a reminder, x equals opposite b plus or minus the square root of b squared minus the product of 4 times a times c all over 2 times the a. And the a is 1, the b is negative 5, the c is negative 29. So, x equals opposite b, so positive 5, plus or minus the square root of b squared, which would be 25, minus, now 4 times a times c, so it would be 4 times the a value of 1 times the c value of negative 29 equals negative 116. So 4 times a times c gives me a product of negative 116. All over 2 times the a value, so 2 times 1 is 2. Now, since 4 times a times c gave me a negative value, I'm actually going to wind up adding things inside the radical. 5 plus or minus the square root of 25 plus 116. So 141. All over 2 times the a value, which is 2. Now, 141 can be broken down at least by 3. So 141 divided by 3 is 47. And I think that's about it. I don't think 47 can go any further. So I really didn't get any lower than the square root of 141 because I don't have any pairs. So that's my answer right there. X equals 5 plus and minus the square root of 141 over 2 and that's classified as 2 real solutions. The last example on worksheet 4 involves some function notation. The problem simply reads, if you take f of x and subtract g of x, you'll get 0 as the answer, and then you'll know what f of x and g of x actually are. So, first thing we have to do is put in, just substitute. We know f of x is 8 over x minus 3 minus g of x, which is 11 over x plus 6, and the problem says f of x minus g of x equals 0. Now the first thing, let's figure out what those excluded values are. X cannot be either positive 3 or negative 6. So there's my excluded values. Now there's an easy way to do this and the hard way of doing this, and let's make sure we take the easy way. All I have to do is take this minus 11 over x plus 6 and move it to the other side. Since this side is 0, it really won't change anything except for this would become positive when it moves over there. So I'm going to have 8 over x minus 3 equals, now the only thing that happens if I move this over there, it becomes positive, equals 11 over x plus 6. And now you're down to those easy problems where it's simply a proportion. There's a single fraction on the left, there's a single fraction on the right, so we know the idea is to cross multiply. And what we're going to get is 8 times x plus 6 is 8x plus 48 equals, now cross multiply the other way, 11x minus 33. And there you have it. It's downhill from here on out. Let's subtract the 8x. And since we swung the x's this way, since we moved the x's this way, I've got to take that negative 33 and move it the other way. And I'm left with 81 equals 3x. Now divide both sides by 3. You get x equals 27 as the answer. Remember our excluded values. X could not equal 3 or negative 6. And my answer to x was neither of those numbers, so everything's good.